Right. It is about stress versus strain diagram. I was told during my morning interaction that you had done the experiment on your universal testing machine. So it is about that only. We'll just do that only, and it is the study of stress versus strain, right? Okay. On this side it is stress vertical, on this side it is strain. Okay. Okay, see how it goes. If I repeat the same exercise, this is the my specimen. That was the lower table, that was the upper crosshead or upper crosshead. Yes, this is the middle crosshead. First we fix the specimen in this middle crosshead. This middle crosshead can be moved up or down using electrical supply only, right? When we fix the specimen into this, then my job is over. Then with the help of hydraulic oil, not with the help of hydraulic oil, then once I'll fix my specimen into this, then with the help of electric supply, I move this middle crosshead into the upside, and then I fix this specimen into between middle crosshead and upper crosshead. Once the specimen is fixed, then this middle crosshead will not move. Then what happens is the hydraulic oil is supplied into this below the lower table, and what happens is inside this lower table there is a cylinder piston arrangement, and that cylinder piston arrangement pushes the piston upward because of hydraulic oil, and because of that oil this moves in the upward direction, and this move also in the upward direction, and this system is an stationary system. Then what happens, this bar will experience tensile force, and that's how we can apply force in this. Now this is a simple mechanism of it, right? Okay, let us just revise that experiment. Now what happens is, when this bar experienced force, and rather one should not say force, it is the internal resistance, and this value of internal resistance is shown in this on this side, and as we can see there are two needles in it. One was called dead pointer, was called live. So this live pointer moves on this side like this, slowly and slowly, it moves like this, and continuously it moves like this. And as this will go from this side to this, from this to this side, then at that very moment we got this type of graph. Then suddenly what happened, we see that it will go back for a minute, and it will go back very few points. Then what will happen, it will go back means value of internal resistance will decrease a bit. If value of internal resistance decreases a bit, that means there is a sudden drop in the value of stress. Why? Because sigma is equal to P by A. Is it okay? Because sigma is equal to P by A. So at this point P was higher, at this point P was lower, and A, area of constant, is A is the area of constant, which is a constant value. Then what we see, that this pointer will remain at this position for few minutes. Okay, then what we realized, that in this span, when this pointer is stationary for few seconds, right? Then what happens is continuous change in length is there. Continuous change in length. Okay. Continuous change in length is there. Then after that what happens is then it will start move like this once again, and it will go like this, like this, like this, right? Okay, and I can draw my graph like this, right? Okay, then what happens is after reaches this value, what it does, it goes back. This needle start moving in the backward direction very quickly. This needle, it was from this stage, it was moving further like this. Then this needle will start go in the backward direction. This will go back, this will go back. Now how to represent this on the curve? Like this only. And suddenly it we hear sudden sound, and at that sound we can see fracture is done, right? So that's how the complete experiment is. And in the same experiment, these are the 4 different sections of it. First section, second, third, fourth. This third is called as strain hardening zone. Strain hardening zone. Fourth is called as necking zone. Second is called as perfectly plastic zone, and this is called as elastic zone. This is what the stress versus strain diagram, and this is for ductile material which can be drawn into wires. For brittle material, I'll discuss during my Zoom class. Thank you.